Okay, so today we are going to introduce quadratic functions. So let's start with that. So what are quadratic functions? How do they look like? How do the equation look like? And how does the graph look like? So we're going to start with an introduction about polynomials. We talked a little bit about polynomials and how we have a monomial, trinomial, binomial, and stuff like that. So a polynomial function is a function that can be expressed in the form of y equals px. Px is the same thing as y, so y equals an, so that's a coefficient x to the power of n plus an minus 1. That's another coefficient x n minus 1, and so on and so forth until we reach a term that doesn't have any more variables. So as you can see, the an minus 1, a1, these are real numbers that are not 0. So this an is not a 0. And the exponents are non-negative integers. So the moment that you have a negative integer, then it's not a polynomial anymore. Okay, so this is just a definition of what polynomial is look like. We're gonna see some examples, and then you'll see the difference between a polynomial and a non-polynomial. So the first one, as you can see, again, f of x, g of x, p of x, whatever, q of x, p of x, and h of x, these are all they can be represented by y. So I can actually, like if you write y, for the purpose of MBF3C, you guys don't need to know f of x and g of x and whatever. But for the people who are taking the 3M course, you will need to know this notation. So this is a notation for a function. That's for you, Eric. So this is a notation g at x, so it's a function of x because the letter here is x. Okay, so if you're looking at this, which is f at x equals to 4x squared plus x minus a half, we can see that this is a polynomial function because you see that all the exponents are positive integers. So if you look at this, this is a 2, this is a 1, this one doesn't have 1. So this is a polynomial function. This one right here, which is y equals 1 minus 10 of x, also it is a polynomial function because, again, the exponents are all positive. This one, y equals x squared plus 5 over 3x to the power of negative 1 minus 3, is not a polynomial function because of that negative 1 exponent. So because we have that negative 1 exponent, that makes it right away not a polynomial function. This one, pi, remember I told you that pi is a number, which is 3.1415, blah, blah, blah. And it's a number, so it's just a constant. It's also considered a polynomial. We call that a monomial. This one, x minus 2 times x plus 4 times x minus 3 over 2, is also a polynomial because if I get to expand this, so if I multiply and do FOIL, right, I will get, at the end, after I simplify, I will get a polynomial function. So yes, it is. Now, looking at what degree is a polynomial, I have to look at the largest exponent of x. So, so the largest exponent of x, so let's look at the first one. So the exponent here is a 2, the exponent here is a 1, and this doesn't have any exponent. So what's the largest exponent? It's a 2, right? So since it's the largest exponent, so we say it's a degree of 2. Second one, it's a degree of 1 because the largest exponent is 1 on top of the x. This one is a degree of 0 because we don't have an x, so x to the power of 0 is 1, and it's gone. It doesn't appear. Now this one, since I have x times x times x, so that's x cubed. Remember we talked about that x cubed represents x times x times x. That all tells me that the degree is 3. So this is a degree of 2, this is a degree of 1, degree of 0, and a degree of 3. Quadratic functions. So let's look at what does it mean for each degree. So a polynomial of degree 0 is called a constant function. We saw that when we looked at y equals pi, right? Y equals pi, that means y equals 3.14. It's a constant function. It's always y is equal to 3.14. no matter what the x value is. So we call that a polynomial of degree 0. It's a constant function. A polynomial of degree 1 is called linear. So if I go back to my previous slide here, this is called a linear function because it's a polynomial of degree 1. It's a linear function where my equation is going to be a straight line. A polynomial with a degree 2, it's called quadratic. So you'll see that the general form of it, or what we call the standard form, is y equals to ax squared plus bx plus c, where a, b, and c are real numbers, so they could be negative infinity to positive infinity, they could be decimal, they could be whole numbers. However, the most important part of this is a cannot equal to 0, because the moment that a is equal to 0, that means I will lose my x squared term and it becomes a linear function. So important, a is not equal to 0 and it has ax squared plus bx plus c. So anytime you see a degree of 2, that's the highest degree, you know that you have a quadratic function. Quadratic functions are very important functions. We see them in engineering, we see them in sports, we see them in architecture. A lot of jobs use quadratic functions, and they're very, very important. We'll see a lot of word problems that relates to quadratic functions. So when we talked about linear functions, we said that linear functions will have a straight line. When we talk about quadratic functions, they look like parabolas. So this is how a parabola look like. So a parabola can have two different openings. So it can open either up, as we can see here, it looks like a U, or it can open down. These are both called parabola. Now there is important features for the parabola. You see that right here. We have what we call a minimum. Right here we have what we call a maximum, because you're going down, reaching a minimum, then you're coming back up, right? While here you go up, you reach a maximum height or a max, and then you go back down. So why sometimes it opens up and sometimes it opens down? It all has to do with the sign of A. So if the sign of A is positive, so it's greater than 0, then it will open up. And this is what I always say to my students is, I'll show you this one. So if it's negative, it opens down. So I always tell my students, so if it's negative, and negative has an N, right? It starts with an N, right? It opens the same shape as the N. Positive, you're always positive. That means you are happy and you open up, right? Positive up. Negative, it has the same shape as the N value. And up has the same shape as the U, right? So up has a U shape and it's positive, and down is when A is negative and it has the N shape. Also, we have other features. As I said, as I was talking about the minimum and the max, we call these the vertex. So these are called vertex. It doesn't matter if it's up, if it's a minimum or a maximum, it's still called a vertex. Now we specify it's a vertex and it's a min, or if it's a vertex and a max. So the vertex is your turning point. Also through the vertex, we have what we call the axis of symmetry. We're going to talk more about these as we go with the parabola. This is just an introduction. This is just like basically if you haven't taken the grade 10 before, or you took it a long time ago, this is going to introduce you to quadratics. We introduced that in grade 10. So the axis of symmetry, it's an imaginary line that passes through the vertex. It's a vertical line that passes through the vertex and is basically it cuts your graph in half. So you see it's called an axis of symmetry is because of the symmetry that it creates, right? So you see if I go from here to here, I need exactly the same distance from here to here. So it's called a line of symmetry, an axis of symmetry. We'll talk about how to find these axes of symmetry and this vertex because they're going to help us with graphing the function. I am not gonna go over these because we're gonna cover them in more details. There is different ways that you can write a quadratic function. So a quadratic function can be written in standard form, which we've seen, which is y equals ax squared plus bx plus c. But we also have the vertex form. So the vertex form is what we're gonna start our MBF3C with, and it's to the form of y equals, again, p of x, just basically it's a function notation. This is for the university level or for the mixed level. For us, for the MBF3C, we just use y equals a bracket x minus h bracket squared plus k. So this is the vertex form. Again, a cannot be 0, and the value of h and k, so you see them right here. So the value h, which is with the x in the bracket, and k, which is outside the x, they represent your vertex. So you can right away from the vertex form, you can find your vertex point. These are the three forms. We're gonna talk about all three of them. We're gonna have a whole unit about vertex form. We're gonna have a whole unit about factored form. So standard form is y equals ax squared plus bx plus c. So that's your basic standard form. This doesn't tell us too much information from the standard form. We'll talk about that later. Vertex form is y equals ax minus h squared plus k. Again, it tells us what the vertex is, and it's the h and the k value. The factored form, you can find the x-intercepts from it. And we'll talk about that. Like, it's this whole process. But you have to remember that I can write the quadratic in all these three forms. So there is a way for me to change from standard to vertex. There is a way to go from vertex to factored. There is a way to go from factored to standard. So there's always like this a method that I can go from one to the other. We're gonna talk about few of them in the MBF3C. We don't cover all of them. So like, for example, we don't cover how to go from standard to vertex, but we covered how to go from vertex to standard. We cover how to go from standard to factored, right? And vice versa. But we don't cover how to go from vertex to factored right away. So it's two units that we're gonna cover. The important part for now is I want you to understand that quadratic, they have the highest degree is 2. They come in 3 different forms. They're exactly the same graph, so I can write 3 different graphs, 3 different functions, but they're the same functions in 3 different ways. And I want you to know that it has a shape of parabola, and I also want you to know that where the vertex is and the axis symmetry. So this is my goal from this lesson. Okay. So right now I am going to post a QR card on the website. I want you to go and attempt that. This is gonna be basically your attendance piece that you have seen my video and you understand what quadratic is, and I will get the results of this directly to my note. Okay, so I hope you enjoyed the quadratics, and I will see you on Tuesday. We'll start our new unit on Tuesday.